We're still waiting on a few folks. Maybe we'll give them another minute to get on. Okay, let's go ahead and get started. Good morning. I'm Aaron Yao. I'm the designated federal officer for the Clean Air Scientific Advisory Committee. In my role as DFO, I'd like to formally open this public meeting. The CASAC is an independent expert federal advisory committee chartered under the authority of the Federal Advisory Committee Act. The CASAC is empowered under the Clean Air Act to provide independent advice to the EPA administrator on the scientific and technical bases for EPA's National Ambient Air Quality Standards. FACA and EPA policy require that CASAC meetings be announced to the public in the Federal Register, and that substantive deliberations and interactions with EPA and the public be conducted in open sessions where DFO is present to ensure that the requirements of FACA are met. FACA also requires that public meetings provide an opportunity for public comment. The panel heard public comments during the August 29th public meeting and also received written public comments. Additionally, at the end of the CASAC deliberations on September 16th, the public will have another opportunity to provide additional brief clarifying comments to the CASAC panel for consideration. Please register with me by 11 a.m. Eastern Time on September 16th if you would like to provide a brief clarifying comment. Minutes will be prepared to summarize discussions and action items in accordance with requirements of FACA. I will work with the chair to certify the minutes and have them posted on the CASAC website. The CASAC consists of special government employees appointed by EPA to their positions. As government employees, the members are subject to all applicable ethics laws and implementing regulations. The SAB staff office has determined that advisors participating in this meeting have no financial conflicts of interest or appearance of a loss of impartiality under federal ethics regulations relating to the topic of this meeting. For those on the phone, I'd like to note that we have a live video webcast for this meeting. To access it, go to casac.epa.gov, click on today's meeting, and you'll see the link to the live video webcast. To those watching the live video webcast, please send me an email indicating your attendance. If you have previously requested a call-in number, you do not need to email me again. I would now like to turn the meeting over to Dr. Leanne Shepard, Chair of the CASAC.
Thank you, Aaron, and welcome to everyone to this meeting of the CASAC Ozone Panel for the purpose of deliberating on the 2020 Integrated Science Assessment in order to help us prepare for our future deliberation on the ozone policy assessment. So today we'll start with brief panel introductions, then we'll cover our discussion points in the order provided in the agenda. Our goal for these deliberations is to address aspects of the integrated science assessment that will inform our advice about the policy assessment. We should focus our attention on topics that will be most informative and impactful for our review of the policy assessment and our advice regarding this reconsideration. I expect we will also have considerable advice for EPA to address in a future ozone review. The proposed order of the agenda is to prioritize the most important topics early in the meeting and also to accommodate availability of panelists. My goal is to complete our conversation of each of the topics on the scheduled day. We scheduled the meetings for 6 hours each day, and my hope is we won't need more than 4 hours on each day. Today, we will start with climate effects, followed by ecological effects, and then ending with ozone and photochemical oxidants. So I'm going to move on to introductions. While we did panel introductions just 2 weeks ago, I think it's helpful for everyone to meet the panel again. I'll go through the roster in alphabetical order, and I ask panelists to turn on their videos when speaking. After the panelists introduce themselves, I'll invite Steve Dutton and EPA staff to introduce themselves so we know who is available to address any questions that may come up during our deliberations. So I'll start by introducing myself. Hailing from Seattle, the most polluted city in the world in recent days, I'm Leanne Shepard, the Roman Haas Endowed Professor in Public Health Sciences at the University of Washington School of Public Health. I'm trained as a biostatistician, and my research focuses on understanding the health effects of environmental and occupational exposures, particularly through the lens of exposure assessment design. So now I invite, George Allen to introduce himself.
Good morning. Thank you, Leanne. George Allen. I'm the chief scientist at ESCOM. That's a nonprofit in Boston. I'm a former chartered CASAC member during the 2010-2014 Ozone Review and the 2011 reconsideration, and been a member of several CASAC panels since 2004. Expertise is in measurement methods and exposure assessment.
Thank you, George. Ed Avall.
Morning. My name is Ed Avall. I'm a recently retired, after 30 years, professor of population public health sciences, formerly preventive medicine at USC. My interest is in exposure assessment and health effects research, and I've been a longstanding researcher in the area of both controlled exposures and epidemiological field investigations. And I have served on previous CASAC panels for ozone, PM, SOx, NOx. Happy to be back. Thank you.
Thank you. Michelle Bell.
Hi, everyone. Excuse me. I'm Michelle Bell. I'm at Yale University at the School of the Environment. I have secondary appointments in the School of Public Health, also in environmental engineering, and also at the Jackson School for Global Affairs. My expertise is in epidemiology and environmental engineering, and my research focuses on how different environmental conditions, including air pollution and other exposures, can impact human health. Thank you.
Thank you. Jim Boylan.
Hi, Jim Boylan, Assistant Branch Chief with the Georgia EPD Air Protection Branch. I'm on my 5th year on the chartered CASAC, and my background includes emission inventories, ambient monitoring, dispersion and photochemical modeling, and state implementation plan development. Thank you.
Thank you. Judy Chow.
Hi, everybody. My name is Judy Chow. I'm a research professor in the Division of Atmospheric Sciences of Desert Research Institute. We're part of the University of Nevada system of higher education. My research interest has been ambient monitoring, different measurement methods, exposure assessment, and source apportionment receptor modeling. Thank you.
Thank you. Mark Frampton.
Good morning. Mark Frampton from the University of Rochester Medical Center. My research interest has been the human health effects of air pollution, mostly using controlled human exposure studies. And our work in Rochester has focused on particulate matter, ozone, and nitrogen dioxide primarily. And my training is in pulmonary and critical care medicine. And I am a former CASAC panel member, along with Jim Boylan, the previous CASAC chartered panel, and have been on PM and ozone panels previously. Thanks.
Thank you. Christina Fuller.
Good morning, everyone. My name is Christina Fuller. I'm an associate professor at the University of Georgia College of Engineering. I've served on the CASAC since 2021, and this is the first time I've served on the ozone panel. My expertise is related to exposure science and epidemiology related to air pollution and associated health effects. and I focus on the fate and transport of air pollutants, disproportionate exposures, and environmental justice issues. Thank you.
Thank you. Terry Gordon.
Hi, I'm at NYU School of Medicine, and my expertise is in inhalation toxicology, a little bit of exposure assessment, and health effects.
Thank you. Catherine Carr is out of town and won't be participating, although she did provide written comments that we'll share during the meeting. Michael Kleinman.
Good morning. I'm Mike Kleinman. I am a professor at University of California, Irvine in the College of Health Sciences. I'm the co-director of the Air Pollution Health Effects Laboratory, and my expertise is in inhalation toxicology.
Thank you. Donica Lombardozzi.
Hey everyone, I'm Donica Lombardozzi, and I am a project scientist at the National Center for Atmospheric Research. This is my first CASAC panel. My expertise is understanding the impacts that ground level ozone has on plant processes, specifically photosynthesis and stomatoconductance, and then the downstream consequences that those have on ecosystem processes.
Thank you. I believe Howie Neufeld is going to be late, so I think we'll skip over him. Jennifer Peel.
Hello, my name is Jennifer Peel. I'm a professor of epidemiology at the Colorado State University and the Colorado School of Public Health. I'm an environmental epidemiologist with a focus on the evaluation of the health effects of air pollution, primarily outdoor air pollution.
Thank you. Richard Peltier.
My name is Rick Peltier. I'm a professor of environmental health science at the University of Massachusetts in Amherst. This is my first go around at the ozone panel for CASAC. I'm trained as an atmospheric chemist, and I work on measurements and cohort studies, largely in developing nations.
Thank you. Next is Alexandra Panet-Gonzalez.
Hi, good morning, everyone. My name is Alexandra Panet-Gonzalez. I'm a professor of geography at the University of North Texas in the Dallas-Fort Worth metropolitan area. And I study atmosphere-biosphere interactions, specifically atmospheric deposition effects on ecological systems. And I focus mostly on forested and urban ecosystems.
Thank you. Jeremy Starnut.
Hi, everybody. I'm Jeremy Starnut from Emory University. I study air pollution, exposure, and health primarily in panel-based settings using mainly molecular level indicators of exposure and response. And I've been on the NOx and PM CASAC panels previously.
Thank you. And last but not least, Jason West.
Hi, everyone. I'm pleased to be here. I'm Jason West. I'm a professor in environmental sciences and engineering at the University of North Carolina. I'm part of the Gillings School of Global Public Health. I'm trained as an engineer and a modeler, and I work on movement of ozone air pollution on really global scales more than anything else. I've been interested in climate and health and policy analyses. Thanks.
Thank you. And now I invite EPA staff if they would like to introduce themselves. Go ahead,
Well,
Steve.
yeah. Hi, good morning, and thank you for this opportunity. We have a good number of folks on the call today. I'm going to introduce myself, and then we'll just have a couple of folks who are going to be sort of leading some of the team from our end introduce themselves. But just know there's a number of us listening on here, and also even more folks from EPA listening on the live YouTube stream. So I'm Steve Dutton. I'm the division director for the Health and Environmental Effects Assessment Division. We're the division that produces the integrated science assessments, and we're happy to be here today listening to your deliberation on the 2020 Ozone ISA. We have a number of health folks who will be joining us later in the week as we get to the health topics. I'll just mention that on the call today we have Tom Lubin, Jason Sachs, and Parker Duffney listening in. But I'm going to see if Chris Weaver, Meredith Lassiter, and Jeff Herricker could pop their video on and say hello. Yeah, I see Meredith and Chris and Jeff. You guys want to all say hello?
Sure, I'll start. Hi, I'm Chris Weaver. I'm the chief of the branch in Steve's division that is responsible for the welfare and atmospheric sciences parts of the ISAs. Let me turn to Meredith.
Hello, good morning. I'm Meredith Lassiter. I am the welfare effects lead on the 2020 Ozone ISA and in the Center for Public Health and Environmental Assessment, and an ecologist. Glad to be here.
And I'm Jeff Herrick. I was the lead back in 2020 on the Appendix 8, the welfare, the ecology welfare appendix. And so Meredith and I will try to answer any questions if there are any. And we have a few others that worked on that listening in.
Yeah, we have Doug Kaler, Chris Novak, Steve McDowell, and Jim Brown listening in for discussions on ecology, atmospheric sciences, and exposure. So we look forward to the discussion. Thank you.
All right. Thank you very much. I think it's time to start on our agenda. And so the first topic on the agenda is the climate effects, which is Appendix 9. And the lead discussant is Judy Chow. So I'll invite her to speak first, followed by Jim Boylan, Jason West, and then Alexandra Panette-Gonzalez. Go ahead, Judy.
Thank you. Shall I repeat the questions? Charge questions? Yeah, I guess.
Yeah,
and
sure.
You want us to break in 3 parts, or just do all together?
I think it's up to you and how you decide you want to present your discussion. I think either way is fine.
Okay. The charge question for the climate effect is in the Appendix 9 of ISA 2020. The question we are asked to respond are, first, what are the panel's views regarding the causal determination for tropospheric ozone and the radiative forcing, and the causal determination for tropospheric ozone and temperature precipitations and the related climate variables? B is deal with have the effect of warming on ozone production have been adequately characterized. Recent findings is consistent with those addressed in Appendix 9 of ISA 2020 that it reiterate the importance of tropospheric ozone in the climate systems. In addition, the increasing tropospheric ozone and precursors and ozone concentrations have been contributed to climate change. However, the 2020 ISA heavily relying on the 5th assessment report called the AR5 of the IPCC that are dated in 2013. As I point out in that there's a lot of going on in the past decades, and some of them probably need additional attention. That, as I shown in the my response, as one important thing to notice for the panel to notice is the evolution of global annual mean tropospheric ozone burden, and it was an increasing trend from 1850 to 2100, and that is really appealing from this graph that from the multiple modeling system that the assessment report 6 of the IPCC clarified the continual warming of the climate system, and over the recent decades, it represents about 19% increase relative to those reported in the AR5. So that's a 20% is big changes. Also, the net positive radiation forcing also increased from the comparison year was 1971 to 2018. That increased about 60% of it. And for the tropospheric ozone burden, that in that graph shows increased 44% from the pre-industrial period. And the most important part is they project the maximum tropospheric ozone burden to 416 teragram in year 2100. So there is a trend to reinforce the global positive trend of the ozone climate force. So it is a causal determination in terms of climate, in the radiative forcing, but I feel probably EPA is recommended to reinforce this causal determination with most recent findings because of the significant changes that I don't find much. It is true that the warming of the climate system, it is true that ozone, the likely to be causal determination for ozone and temperature precipitation was assessed in the 2020 ISA. But please note that ozone is the third largest anthropogenic greenhouse gas contributing to radiative forcing. With, although the total forcing is not as high as those of other gases, but it's still pretty significant. But I find that the ISA 2020 did not really address the effect of warming on ozone production. The frequency, intensity, and the duration of the heat waves we're all experiencing in recent years, they really accelerate the regional feedbacks and local emissions, which can increase the surface ozone concentration as well as the intensity of the peak concentration of ozone. That there's very little has been discussed about the temperature increase and drought and their consequences of the ozone. So I feel that those need to be really determined. That the assessment report 6 reiterated a positive response of surface ozone and the future climate change through wildfires, soil NOx emissions, and the stratospheric ozone exchanges. So that in my response, I give a few examples on the ozone extremes and heat waves and drought and the specific weather patterns coupled with the local emissions. And especially a study they noted that northeastern and southeastern US will have strongest dependence between the temperature and the extreme level of ozone. That so there's a warmer condition in the future will have potential increase ozone level with subsequent adverse environmental and health effects. So in conclusion, given the important temperature and the ozone relationship that, EPA is encouraged to really emphasize on give more attention on that, better understand the vertical profile of the ozone distribution, the precursor gases emissions, and this is a multi-pollutant approach. I point out that in my response in Germany, they find out that the large increase in NOx will result in a NOx-limited environment, which will change the ozone photochemistry. So those really need to be deserve additional consideration. And given the temperature dependence of ozone, the warming effect on ozone, and it's encouraged to be considered, may re-examine the likely to be causal determination, to be the causal determination between the ozone and the temperature. Thank you.
Thank you, Judy. Next up is Jim.
Yeah, so first of all, I'll start out that I agree with EPA's causal determinations for radiative forcing and climate variables. I agree with Judy that the effect of warming on ozone production has not been discussed in the document. I didn't see that in there. The ISA states that the increase in tropospheric ozone abundance has contributed an estimated 0.1 to 0.3 degrees centigrade warming to the global climate since 1750. And to me, it's unclear if this amount of additional warming would significantly impact ozone production. I know we're supposed to focus on material that would inform our upcoming review of the policy assessment, and this is an unusual situation in which we already have the draft policy assessment in our hands before we discuss this ISA. But since we have it in hand, the policy assessment, draft policy assessment released in April, states there are limitations in current climate modeling capabilities for ozone. Such limitations impede our ability to quantify the impact of incremental changes in ground level ozone concentrations in the US on radiative forcing and subsequent climate effects. And so basically, when it gets to the policy assessment, they don't really do anything with the information because it's too uncertain. So I guess my comment is, although I know Judy had some really good new information, to me, I don't know if any of that would really change the conclusion about bringing this analysis into the policy assessment. That's all I had.
All right, thank you, Jim. Jason West.
Okay, hi everybody. As Judy said, we're in an unfortunate situation here that the last that the ISA that we have before us was drawing information from the last IPCC report, and since then a new IPCC report has come out, and that provides a good view of what's new in the science. That said, I didn't really pick up on many themes that were, without having gone through extremely carefully. I don't anticipate that the conclusions reached here would be very different if they were also drawing from the new IPCC report, as well as, the last couple of years of published papers. So while I think that's a concern, I think in practice that, the new IPCC report has reached conclusions that are largely consistent with those of the old IPCC report. And so I don't know, Judy had made a couple points regarding extreme weather, et cetera, that I thought were interesting and worthwhile to consider. But overall, I don't think the basis for reaching conclusions here is that substantially different than it was before. One of the impacts of ozone on the climate system that I didn't see represented here was that ozone slows plant growth, and as such, it has an effect on the global carbon cycle. So by slowing down plant growth, it is suppressing the take-up of CO2 by plants and growth by plants. And so atmospheric CO2 is higher than it would otherwise be. There could be, I suppose, some definitional issues about where is within the document. Is that a climate effect or is that an ecosystem effect? And it's probably both. Nonetheless, I didn't see that mentioned here. So that's yet another way that ozone affects the climate system beyond directly having a radiative forcing. So EPA's determination was that there is a causal impact of ozone on radiative forcing, and likely to be a causal impact on climate variables, including temperature and precipitation. I agree with the causal impact on radiative forcing. This is based mainly on understanding of the absorption of radiation by the ozone molecule, but then putting that into a climate model to understand what's the impact of ozone with respect to other greenhouse gases in the natural atmosphere. So I agree with that causal impact on radiative forcing. The conclusion that it's likely to be causal on temperature and precipitation and other variables, I would say I disagree with that. I think it's possible to say that there's a stronger relationship there. I would say that it's causal. in that if there is a radiative forcing, then it's almost by definition that there would be a temperature change. So how the Earth responds to a radiative forcing is through a change in temperature. There would also likely to be changes in precipitation patterns and weather patterns broadly. So there's a difficulty in that we have difficulty through modeling attributing particular changes in temperature or precipitation specifically to the change in ozone concentrations, we could say. So that's a bit of a definitional issue. What is necessary to have this causal determination? But it strikes me that this case is really pretty different than how we're thinking about, for example, the impacts on ecosystems or impacts on health, where from epidemiology, we're dealing a lot with statistics and using those statistics to make a causal or not causal statement. Here, there aren't studies that would relate ozone statistically with temperature or precipitation. Rather, it's a different line of evidence, and that line of evidence comes from understanding ozone's effect on absorption of infrared radiation going out from the Earth, to understanding the impacts of that on radiative forcing, to understanding then that there would be a temperature change. I'll point out that the last IPCC report and the draft, the ISA, the appendix before us here, put a range of the impact of temperature change being, if I remember right, 0.1 to 0.3 degrees Celsius attributed to ozone. That range of uncertainty does not span zero, which means to me that there is a temperature impact of ozone globally. The precipitation change is harder, and the patterns of those temperature change are a bit harder, but it seems clear to me that there is a causal influence on temperature if the range of temperature cited doesn't include zero. That is to say that we have confidence that there is an effect on the global temperature. And I'll just mention that I think that that's in line with what the new IPCC report also says about it. It gives a range of temperature that doesn't include zero. So just to conclude, I support the conclusion that there's a causal impact on radiative forcing. I think the language for temperature and precipitation could be stronger and stronger than likely to be causal, and in fact could say causal. But I understand that there might be a difference of opinion about that. Okay, so thank you.
Thank you very much. Next up is Alexandra Gonzalez.
So I don't have a whole lot to add. I think the other panelists have done a great job discussing the causal determinations. I also agree with those causal determinations, both for radiative forcing and the likely to be causal. But it did seem to me, based on the evidence presented, that the likely to be causal determination for climate-related variables was more based on the fewer studies that are available on ozone effects on precipitation and atmospheric circulation than on temperature. So kind of following up on what Jason was saying, there seems to be a lot more evidence for temperature than for precipitation and atmospheric circulation patterns, but they're all kind of lumped into the same determination. Like Judy was saying, I also found that there wasn't any discussion of warming effects on ozone production. And I think it's fair to say, I'm just echoing what Judy was saying, that there is quite a bit of evidence in the last several years to support the effects of drought and heat waves and stagnation events on ozone concentrations. And I think also there's been an explosion in the literature on warming related wildfires and how that's increasing ozone concentrations. So again, I don't know how that whether or if that changes the causal determinations, but those are some of the things that we're seeing over the last couple of years that might be beneficial to include in this review. So with that, thank you very much.
Thank you. And now I'd like to open it up to any members of the panel who wish to comment on this topic.
I'd just like to make one brief comment, and that is that, from the previous reviewers have, I think, nicely summarized sort of what has changed in terms of the additional information available from the IPCC reports in 2013-14 and the ones most recently, so the AR5 to AR6 reports that have come out. And again, I think, in general, one might say that the newer reports have added more confidence and, sort of not earth-shattering differences that are found so much as just more confidence in what is being seen. And I think that sort of sense of more confidence in what is being seen ought to be a consideration in the ISA, review and consideration as well. That there's more confidence, and that sort of I think sort of works into the comments that Jason was saying that that there, maybe the suggestive or could be causal, is more confidently assessed now because there is more information that supports that in the IPCC reports. Thank you.
Thank you. Terry.
Yeah, I didn't read Appendix 9. Could someone remind me how this climate effect affects our deliberations on the NACs, which to me is mostly health effects for the primary?
I don't think this is about the secondary standard, is my understanding.
Oh, okay.
It's not about the primary standard. And I think that one of the important things that we've heard in various ways and has been a topic of conversation from multiple ozone panels in the past, and those of you who have been on these previous panels could maybe chime in on this so I don't misrepresent it, is the importance of setting a separate secondary standard. So one of the reasons why actually not only panelist availability, but one of the reasons why I put these topics on the agenda for the first day is that I think that this is something that we want to weigh in on fairly strongly about what we think about the importance of a separate standard for the secondary standard. And this and the next topic are very important for driving that. So the advice here, or what I'm hearing, is the suggestion that we now have enough information to change the conclusion for the temperature and precipitation effects to causal is an important piece of advice.
And if in doing so, to changing it to causal, recommending it be changed to causal, is there quantitative data for helping set the secondary standard?
Again, I'm probably speaking a little bit out of line, but I believe that most of that is driven by the ecological effects, which we will come to next. Does anyone else want to chime in on this topic? Jim?
Well, I think I'll just repeat what I said before. I mean, since the question has come up about how does this get carried forward into the policy assessment, we have the policy assessment in hand, the draft policy assessment from April. And basically what EPA said is that due to the limitations in the current climate modeling for ozone, basically they can't do anything with it. And they just kind of leave it at that. In that, there really is no additional analysis past this. It's not, there's no numbers looked at or there is no secondary standard for climate or radiative forcing discussed in the policy assessment because of the uncertainties in the modeling. So this is a case where we can bring these, make these comments, but I really don't think it changes anything in the policy assessment.
Okay, thanks for that, Michael.
Yes, thank you. This is sort of an aside, but part of our recommendations, I think, is to discuss what additional research would be useful. And it might be helpful if we could make some comments about addressing some of those limitations and what could be done in the future to fill in those data gaps.
Yeah, that's helpful, and I would encourage that's a good point. I should have probably mentioned at the beginning. I would encourage everyone, particularly the lead discussants for every section, to highlight that, because not only are we wrapping our heads around the scientific evidence in order to give advice about the policy assessment in a future meeting, but we are also, in reviewing this, I think we can actually point out things that could be done, future research, and also ways to approach the next review. So that those are important things that we should comment on in our feedback to EPA. Judy.
Yeah, I just wondering how EPA's response on this, because the last meeting I raised the question about AR6, and the EPA doesn't believe there's much changes. But with this recent, after I did this literature search to find out that this warming effect, especially AR6, introduce a self-service ozone penalty of 0.2 to 2 ppb per degree Celsius. So that's probably worthwhile for EPA to comment on that, and to also get into the consideration for the future.
Thank you. Is there someone from EPA who would like to comment? Chris?
Yeah, sure. Thanks, Leanne. I can comment, and I think, maybe address quickly sort of a connected collection of issues raised. So first to Judy's point about the IPCC, back in 2020 for the ISA, the only IPCC assessment report we had available to us was AR5. The AR6 wasn't published till after the final release of the 2020 Ozone ISA. Of course, the AR6 contains lots and lots of new climate science. As Jason said, there's not a lot in there that would change our determinations about the effects of ozone back on climate. So, ozone effects on radiative forcing and temperature and so on. And I think to, the sort of second point that Judy made and also Alexandra echoed, yes, there is, a well understood and progressively getting better and better understood effect of climate on ozone via changes in precursor emissions, meteorological conditions like stagnation, drought, wildfire, and so on. That's not in scope with the ISA. We haven't looked, for any of the criteria pollutants at the effect of, or included in the ISA and in the causal determinations, the effects of climate on those pollutants. We've looked at, because it's part of the definition of welfare in the Clean Air Act, the effects of those pollutants on climate, but not the other way around, right? And so we are, that's the way that the ISAs have been scoped. Of course, EPA is very concerned about the effects of climate on air pollution, but that's covered in, different assessments that we do. Those sort of branches of the system, the sort of climate ozone interaction system, have not been brought together in one assessment, the ISA. So to the point about, I just wanted to address Jason's point about the difference in causal for radiative forcing likely to be causal for temperature, precipitation, and other climate variables. In the 2013 ISA, the history of this is that there were two causal determinations in the 2013 ISA, one which was called radiative forcing and one which was called climate change. And climate change seemed, there are certainly potentially definitional issues with the way we've done that second causal determination now, but it seemed like there were significant definitional issues with having radiative forcing and climate change, because of course you can argue that radiative forcing is could be folded into climate change. So we wanted to be more specific. The problem is, as Jason and Alexandra noted, we are sort of mixing together a variety of variables: temperature, precipitation, atmospheric circulation changes. And I think that, I agree with Jason that almost by definition, if you have a change in radiative forcing, you have a change in temperature. It may be harder to sort of directly attribute the proportion of that change in temperature to the kind of incremental ozone greenhouse gas forcing. The lines, we don't have, for example, direct observational lines of evidence like we can observe to a certain extent more directly the radiative forcing associated with ozone alone. We have to model it. But as he said, it doesn't span zero, right? So there's an effect there. It's much harder to tease apart, I think, the downstream effects on precipitation and atmospheric circulation changes from all of the other factors and feedbacks that are working together in the climate system. And so I think, calling that likely to be causal instead of causal, I think, is an attempt to, across that spectrum of variables, create that a little bit of that distinction in the sort of evidence base and the kind of downstreamness of the impact. Let me stop there.
All right, thank you. So if I'm hearing you correctly, because there's some uncertainty in some of the other aspects that aren't temperature, that was driving a lot of the likely causal determination. Is that
correct?
A way of putting that?
Yes.
Okay, thank you. Alexandra.
So I guess I have a question then. Would it make sense for us in our comments to suggest the possibility of creating a separate causal determination for temperature, separate from precipitation and other climate-related variables? Would that be helpful?
Is that a question for me or for Leanne?
I think for you, for everyone, actually. Maybe everybody on the panel, Leanne, you, Chris.
Yeah, I think let's start with Chris, since you're the one that does the work.
Yeah, I mean, I think that kind of suggestion about how to further refine how we define kind of the scope of each causal determination is certainly helpful for future reviews. Those opinions that maybe the evidence base is starting to bifurcate, right, can really help us. I mean, we do that. We take causal determinations that are lumped together in one review, and then in a subsequent review, we kind of separate out the distinct evidence bases because there's enough basis at that point to say something different about the pieces of that effect. So I think that can be very useful certainly very useful to us to get advice about where we think that sort of bifurcation is occurring in the literature, and we can structure around them.
Okay, thank you, Jason.
Thanks for that explanation. It helps me to understand a bit more what EPA was thinking in the causal determination. I just wanted to point out that, radiative forcing isn't really an observable quantity. It's a bit of a modeling construct. It's not actually a real thing. So to have a separate determination for that, the only way you would observe it would be by looking at the Earth from a satellite out in space and integrating the infrared radiation you receive over time. And that's been done, but it's really not. And then you'd have the trouble of separating out what the ozone influence is versus carbon dioxide and water vapor and other things too. So that's one of the problems here is ozone is integrated with all the other ways that we're affecting climate too. So it just seems a little, it's fine on the one hand to say that it affects radiative forcing, but radiative forcing isn't something that is going to have an impact by itself. It's only through changes in temperature and other things that it has an impact. Again, I think the evidence is strong that there is a global temperature impact. I think the evidence is also strong that we're changing, as climate changes, it changes precipitation patterns and temperature patterns as well. It changes the frequency of extreme events and things like that. There's a lot of evidence for all of those things. What's missing, though, I suppose, is what is the contribution of ozone in particular to those things. But if the question, if the bar for causality is that that ozone affects climate, it is clear that ozone affects climate. And I would call that causal. If we need to be able to pinpoint it's affected climate by this many degrees and this many millimeters of rainfall in this location, I don't think we quite have the ability to do that with high confidence. Thanks.
Yeah, there's a lot of great points there, Jason. And I think that, your distinction about radiative forcing being a modeling construct. Yeah, I mean, we need recourse to, line by line radiative transfer codes and so on in order to get to those, fairly precise numbers that show up in the tables in IPCC, right? And so I think that that's a very fair point to make. I think there's some, I think some of the kind of sorting into categories, into causality categories is driven in part by where the literature has gone and what sort of literature we have available to draw on. And so, those tables and those graphs, those bar charts with radiative forcing attributed to different radiatively active species, they've been around in the IPCC assessment reports for a while, and for the relative contribution of ozone, as you said, the story isn't that different in AR6 compared to AR5, and really not that different compared to AR4. That's a pretty mature body of science. But you're right that radiative forcing has to manifest as some kind of change in temperature, right? And so what I almost hear you saying is, but we don't have that kind of attribution type study. There are very few papers out there that get you to that 0.1 to 0.3 degrees C, ozone attributable warming. But I think almost what you're saying is that maybe temperature and radiative forcing go together better in a causal determination. And then downstream impacts of the atmospheric warming may go together better. Sort of in their own. Temperature and radiative forcing are two sides of the same coin. The other variables are mediated by more complex interactions and feedbacks in the atmosphere.
Okay, that was a helpful, robust discussion. Is there any more comments on this topic? Michael.
Yes, I may have misinterpreted what I heard Chris say earlier, but one of the things that is not addressed in the ISA or the PA is the effect of climate on the pollutants. And I think that there's an important feedback there in terms of the implications. For example, in areas of drought or during, as precipitation is reduced, the cleaning of the atmosphere for precursors of ozone and PM and other things is also reduced. And I think those implications really should be at least mentioned a little bit more or thought about more, because I think they can have effects all the way through in terms of concentrations of pollutants and effects on health. So, I mean, it's very interactive and sort of circular in the way this works out. But I think that complexity should be brought out as well.
Yeah, you're right, of course, that it is circular, that climate affects ozone, ozone affects climate, and there's direct and indirect pathways, connecting both. And, we, as I said before, we are not systematically reviewing the literature in the ISA for the effects of climate on ozone. We're doing the, hard to separate out, as you correctly note, reverse side of that branch, the effects of ozone on climate, because climate is listed as an effect category in the Clean Air Act. We try to give a little bit of flavor of that complexity in the ISA diagrammatically, sort of showing those different branches. Let me see if I can point in the direction. We have a figure in Appendix 9 of the ISA 9.1 that we also pull forward into the integrated synthesis that kind of shows overly simplistically, but graphically, some of those effects and the associated feedbacks. But then we don't, we only focus our systematic review on the impacts of ozone on climate. But of course, it's embedded within a complex system of interactions and feedbacks.
Okay, thank you. Any further comments or questions? Discussion? Judy, do you think you have what you need to work with your discussion group to write up some comments for our consensus responses?
Yeah. Yeah, I still puzzle about Chris's claim on that EPA would not, cannot do a systematic review on the effect of climate on pollution or on ozone. Because I felt that even though they are not as much changes from AR6 to AR6, 5 to 6, but they're definitely more positive trend, and 90% is not insignificant increase from the AR5 to AR6 in terms of the radiative forcing. I think I forgot which one was it, but and the climate penalty is clear. That I don't want those information get lost because the fact that climate is not really kind of embedded in the standard, next secondary standard. So I felt that I don't see that. I would like to see EPA really adding to the recent findings for the past decade. But I guess we'll put in the response if it's okay with the panel member.
Yeah, just to be clear, we could do a systematic review of that. That would just be a different assessment report. It wouldn't be the ISA. We haven't included that in the ISA to this point, right? In the history of us doing the ISA. So that would be, adding a body of literature to the ISA that we've looked at in other EPA reports and other EPA research, because of course, we're well aware of the impact of climate change on ozone and the ozone penalty. But that has not been part of the body of work that is systematically reviewed for the NAAQS reviews.
So will EPA consider to look into the warmer temperature warmer on ozone, like treat that separately, because there is a positive causal determination. But when you lumped with other climate effects, then it's uncertainty. There are also multiple evidence in terms of modeling improvement over the years. And the figure I cited, I put in my response, it comes from many, many different modeling research in terms of the time evolution of global annual mean tropospheric ozone burden. And it's really true, this heat wave, and we cannot be, ignored. I have trouble to have ISA 2020 based on 2013 information that seem to miss, that's not really adequate to that inform the public that things has been changed. And there's, reiterate the importance of radiative forcing, really important. So heat wave, along with the AR6 mentioned soil NOx emission, troposphere interactions, and the wildfires. So I felt those are important points need to be put somewhere to really inform the public.
Maybe they should in part be brought into the policy assessment.
I've always had trouble to see which one goes where.
Jim.
Well, this might be a question for Judy, just to help me understand. So the climate penalty 0.2 to 2 ppb per degree C, and we know that ozone is impacting global climate temperatures by 0.1 to 0.3 degrees C. So can we just multiply the two together to get a range? And if you do that, 0.02 to 0.6 ppb, I mean, is that appropriate to multiply those together? And if you do 0.02 to 0.6 ppb is what you get, is that a significant impact or not? Or do we know the answer to that?
Okay, I forgot to mention that the positive response for surface ozone penalty of 0.2 to 2 ppb per degree C is over polluted area. So that's why we see a distribution of ozone 1% increase and the 95% decrease, because ozone knows that warmer climate reduces surface ozone in unpolluted regions due to the increased water vapor absorption, and that accelerates some ozone chemistry losses. So it's not a linear function. So I don't know if you can. That's a pretty interesting way to look at it. That it's interesting that is AR6 did not really repeat some of the bar graph on AR5. They lumped the ozone with the methane. So it really did not. They did mention the 0.1 to 0.3 degrees C increases, but after all, the ozone, global ozone, sometimes it really have to be regional specific. Does that answer your question, Jim?
Yeah, I guess it just sounds complicated. So
it is complicated issue. That's why it's kind of disappointing that over the past decades, there's not much effort. I know I had a study I'm pointing out in Las Vegas. There's just not much study to better understand the ozone precursor concentration, to understand the vertical profile of ozone, to treat this as a multi-pollutant information in terms of potential NOx reduction due to the electric vehicle fleet getting the atmosphere, all that will affect the ozone. So it's a lot of things just not really being dealt with in the past decade.
Well, that would be something to make sure to add to the comments about future research topics as well. Because I think that will be helpful to EPA since we can't change this ISA. Mark.
Yes, just a question that I guess I'm having trouble. I understand the importance of the potential importance of change in temperature and climate change on future ozone levels, but really for the PA and for the issue of the secondary standard, we're interested in what the effects of ozone are on the environment. And So I guess I'm not seeing how adding that to the ISA is going to impact the PA and the standard setting process. Am I missing something?
Is there anyone that wants to chime in on that question?
Well, this is Jim. I mean, I would agree with Mark that I don't think it's going to impact the standard setting process when we move over to the policy assessment. I mean, I think this is good information to have and maybe some good future research, but as far as moving on to the policy assessment a couple of months from now, I really don't know if it's going to have any impact on the standard setting.
Okay, thank you. And maybe that is an opportunity to close out this discussion. Any last questions or comments? All right, so let's take a just a couple minute break and come back at 10 after the hour. That's in 4 minutes by my clock, and then we'll start on the ecological effects.
Hey, well, I got your comment about my audio. I wanted to see if it was any better.
That sounds fine.
Oh, so it's
Yeah.
fixed?
Yeah, I don't know what it was. It was just really
All right,
hollow.
no,
Tinny.
there
Sounds
was
great.
an enhanced little checkbox that I don't think is normally checked, but it was checked, so I unchecked it. And
Great.
here we are. That's good. Thank
Perfect.
you.
You bet.
Okay, welcome back, everyone. We're going to start now with the ecological effects. And so the assigned discussants for this section are Alexandra Panett-Gonzalez, Donica Lombardozzi, Howie Neufeld, and George Allen. So Alexandra, are you on and ready to go?
I am here and ready to go. So I'm going to go ahead and start by reading the questions. The first question was, what are the panel's views regarding the summarization of the scientific evidence on effects on vegetation and ecosystems from ozone exposure? I think Appendix 8 provides a comprehensive and a well-written review of the scientific evidence. And this is for the period from January 2011 to March 2018. The second question, is the summary adequate? And I was doing some math this morning as I was walking my dogs and thinking, wow, that's been 4.5 years have passed since the end date of that literature review. And so in looking at the literature, I found that there have been quite a few studies published since March 2018 on ozone impacts on vegetation and ecosystems, providing new insights on how ozone affects plant phenology, plant reproduction, pollination, and plant insect interactions. Now, I didn't see any evidence that these would change the overall causality determinations presented in the appendix. So I do think that the summary is adequate to inform the PA or the policy assessment. In terms of the third question, I actually wanted to just comment in terms of future reviews. There was a section on modifying factors. And I think in the future, there are some opportunities for more literature review on how ozone might interact with particulate matter, not just nitrogen, to affect vegetation and ecosystems. And I think there's also an opportunity to review more closely how ozone impacts urban vegetation, especially given the consequences of that for human populations. In terms of the second question, does the evidence review provide adequate background for consideration of alternate forms of the secondary standard? I think it does. It was very clear to me in reading this that the appendix makes a very strong case, or basically says that the cumulative weighted indices are the most widely used in the literature and the most appropriate for understanding ozone impacts on vegetation and ecosystems. And I would say by extension for protecting vegetation and ecosystems. So it was very clear to me that those are the best indices. And rather than elaborating on that point, Donica and Howie and George had quite a bit to say on that point. So I'd like to let my colleagues talk a little bit more about the secondary standard.
Okay, thank you. So up next is Donica.
Sorry, having some trouble finding my controls. Yeah, well, thank you for the opportunity to be here again. This is, I think that this is really important to consider. As Alexandra pointed out, I think I focused mostly on my area of expertise, thinking about ozone uptake and damage to photosynthesis. As Alexandra points out, and I did not include this in my written comments, there are some updates to the literature, but on other, non-biomass, non-photosynthesis quantities, but I agree that they don't necessarily change the summary. I do think this is really quite a comprehensive review, and it's wonderful to see all the information compiled in the same place. One thing that I'll point out is that there's a new study by Lee et al. That was just published this past year, 2022, that suggests that plants might actually be more sensitive than previous literature suggested for the W126 value. And so I think that this new study could be incorporated. I think it would change the findings in the sense that it would, I would argue that the policy assessment needs to consider a lower W126 standard based on this work. The second thing that I wanted to point out is that the scientific literature does highlight that there are relationships that account for stomatal uptake of ozone that are typically stronger
predictors of plant damage than exposure-based metrics. And the difference there is plant uptake accounts for plant health by thinking about the stomatal flux of ozone, because being the external ozone exposure of a plant is only one of the variables that confers ozone damage. And so if we account for stomatal uptake and the amount of ozone that's getting inside the plant leaf, then that is much, research has shown that that's a much stronger predictor of ozone damage. And so I think that that is missing a little bit from this policy, or sorry, from this ISA. The ISA did highlight some work by Sands et al. In 2016 that also highlighted that the metric for stomatal uptake was a stronger predictor of reproductive loss in a clover species, for example. Victoria Wittig and colleagues in 2007 published a paper that has a summary of 28 tree responses to ozone, and that highlights to ozone uptake, I should say, and that illustrates a photosynthetic decrease of 22% per 100 millimoles per meter squared ozone of cumulative ozone uptake per unit leaf area. And so I guess the one thing that I will highlight is that I know that this accounting for ozone uptake requires additional information on plant health, namely stomatal conductance. That is not an easily widely measured quantity, but we could use models to estimate stomatal uptake. And I will also point out that this is the phytotoxic ozone dose, which is effectively the same metric of accounting for a cumulative stomatal flux of ozone, is being proposed for use, or maybe even implemented for use in the European Union. The other thing that I'll point out is that some recent work led by Arnav and colleagues that was also published in 2022 illustrates that concentration-based metrics like AOT40 and W126 don't always capture the spatial patterns of cumulative stomatal uptake. And this is because high ozone concentrations can co-vary with conditions that coincide with stomatal closure, things like drought stress, because ozone reacts with water vapor in the atmosphere. And so when you have less water vapor, and also when plants are drought stressed, they close down their stomata. And so this particular study shows that estimates of photosynthetic can be lost and actually be higher using concentration-based metrics than using more of a stomatal uptake or phytotoxic ozone dose metric. Related to the scientific evidence to support a secondary standard, I would say that it's there. It's in this integrated science assessment. And I strongly encourage that the policy assessment considers this secondary air quality standard, because the evidence is there. And in particular, the evidence is there to suggest a single year ozone metric, which currently right now it's a 3-year average metric, but a 3-year average metric does not account for cumulative impacts on plant health as well as a single year, and it also does not capture the impacts of on annual plant species that don't grow longer than a single year. And so I think that we really need to consider a 1-year ozone standard. And this is actually highlighted or stated in section 13.1 of the appendix. So I think that, I think the evidence is there. And I'll also add that it was not made clear to me in the policy assessment. And I think that we can't confidently use the W126 metric. It's not met, I guess, or we can confidently use the 126 metric, but it's not met by the primary standard of the forest highest 8-hour average ozone concentration, because these values are sigmoidally weighted. And so there's no evidence that suggests that primary standard means that you meet the secondary standard, which is what the policy assessment states. So I very much strongly encourage reconsideration of that metric as well.
Okay, thank you very much. Next up is Howie Neufeld.
Yes, thanks. I'm not going to go into a lot of detail because my two colleagues here have already said a lot of what I agree with. There are some new papers that have come out in recent years. I mentioned just one, the Lee et al. Paper, which redid the exposure response curves. But even though there is this new literature, I don't think it changes most of the causality relationships that are put forth in the ISA. So while it's nice to have that literature in there, I don't think it's going to broadly change our levels of causality here. And I do agree in the section, I have missed this once before, but the variability of outcomes regarding interactions in climate change and ozone. As the EPA notes, it's coupled with a relatively small amount of the literature in this area, and their conclusion that it's difficult to make broad generalizations seems justifiable. But we are starting to see the trends such that rising CO2 can cause some stomatal closure. It can also provide additional carbon as resources for defense and so on. And there may be that interaction. The one that's probably the least studied is the interaction of warming and plant response. It gets quite complex because of the dynamics of how stomata respond to warming and how they respond to ozone simultaneously. There's not a big literature on that, but that would be something to look at in the future. So in summary, I think the causalities as outlined in the ISA are reasonable and sufficient to inform the policy assessment. I agree with my other two colleagues about the secondary standard. I quoted a section in section 8.1.8.13.3, which says, given the current state of knowledge and the best available data, exposure indices that accumulate and differentially weight the higher hourly average concentrations and also include the mid-level values, for example, the W126 or AOT40 metrics, continue to offer the most defensible approach for use in developing response functions and comparing studies, as well as for defining future indices for vegetation protection. And I agree with Danica also that flux is probably going to give us a better indication of how the plants are responding to the ozone. But it's extremely difficult to do, and especially in a country as large as this, I think, and we haven't had the funding to do the kind of studies that they've been doing in Europe and in Asia. It might be something to look down the future for, but we don't really have it in hand right now for North America. And I put forth just a suggestion that we should have a one-year secondary standard based on the W126 metric. And just put forth some ideas about what it might be, but don't take that as set in stone or anything like that. But it does lower the level from what is currently used in terms of considering what would be a W126 metric. So from, I think, 17, and this one goes down to 10 or so. So I think that's something at this point in time, given all the strong support for this separate secondary standard, that that we really need to seriously consider doing that. So I'll leave it at that at this point. Thanks.
Great, thank you. George, you're up next.
All right, I'm batting cleanup here. The short answer is I agree with all of the other folks in this subgroup. You know, there's really this is one of the simpler topics in the ISA. It's really robust, and unlike health effects, the causality determinations for all of the ecological effect endpoints, they're all causal or likely causal. Now, maybe you could argue that some of the newer literature out there might move some of the likelies into causal, but for the purposes of the PA, it doesn't make a lot of difference. And this hasn't really changed since the review done in 2006. You know, there's some new endpoints and some different definitions, but you know, it's all been there. Ozone effect on plants were well established back, you know, 2 decades ago, essentially. So yeah, there's some new literature, but I don't think it's, you know, in the last decade, or certainly since the last review even, I don't think it changes any of the conclusions regarding the key ecological effects, especially on vegetation. And I concur that, the discussion about using a seasonal weighted W126 is very appropriate, whether it's 1 or 3 year form. I'm sure we'll be talking about that when we do the policy assessment work. The issue for me here, and this is where I get a little grumpy because I've been around this loop once too many times, is that EPA has insisted, going back to the 2008 decision, on saying, and this is important, contrary to consistent CASAC advice, in the last several reviews, that the primary standard provides adequate ecosystem protection. And I'm just like, okay, I don't know how we move past this, but Leanne, I'm glad you put this up front, because I agree that this discussion, which is probably more of a PA discussion, would be an important topic for the CASAC review of the PA when we get there. So really, that's it for me. Don't have much to add from what's been discussed.
All right, thank you. And a seed I'd like to plant is for our discussion on Wednesday is while the evidence for the long-term exposure and health effects isn't as robust as might be needed to drive a primary standard, setting the secondary standard, which is very strongly justified, might actually have some important health protective benefits for long-term effects, which seem to be emerging. So just plant that seed and ask people to reflect on that a little bit. That this is maybe looking ahead more to the policy assessment than we should be, but that'd be something to also think about in the advice we give. Any comments or questions or topics for discussion from anybody on the panel? Jim.
Oh, yeah, I'll make this quick. I liked a lot of the suggestions and the discussion that we've had. And I agree with a lot of what I heard. I do want to encourage us to, stick with the science piece of this as we're making recommendations. And we talked a lot about policy things such as 1 year versus 3 years and certain levels that people are recommending, and using the primary standard as a conservative estimate of the W126. I think all those are policy assessment discussions and probably should not be included in our comments on this document. But yeah, definitely should be included when we go to the policy assessment.
Yeah, and as you've already stated, we're in this unusual situation where we already have the draft policy assessment, and we also are commenting on an ISA that's finished. And so it's a little bit, I think, hard for all of us to separate these two things. But you're absolutely right. When we write up our consensus comments, we need to focus on our review of the science in terms of how it informs the policy assessment, as well as any advice we can provide for future research and future EPA reviews. But yeah, thank you. Well, I thought this would probably take up the most discussion of the day because it's such an important topic, but it seems like the evidence is just so clear, there's not much to say. Is that a fair assessment? And maybe I'll turn it back to you, Alexandra, and see if you want to, if you feel like you need any more information to lead up the written response.
I think I have what I need. I think this is good news. There's strong consensus among us.
Yeah, and not too much more to say until we get to the policy assessment. Well, we're blazing through our agenda. We only have one topic left for today, and I think it will make the most sense to not try to talk about the topics that are on our agenda for Wednesday, even though they may take a lot more time. But I think we'll move on now to the last topic for today. And talk about the ozone and photochemical oxidants. And the lead discussant is Jeremy Sarnat. And the additional discussants are Ed Aval, George Allen, and Rick Peltier. So, Jeremy, are you ready to start on this?
Well, I guess I'll have to be ready right now, but I think I'm ready. And you know, if I forget anything, I'll just try to circle back to it as well. But this was a discussion point 2, and I'll just kind of restate the question itself, which is, what is the panel's view on evidence pertaining to distinction between exposure to laboratory generated ozone and ambient ozone? And the charge specifically asks us to focus our attention on aspects of the evidence that will inform consideration of the weighting of health effects evidence from controlled human exposure studies and EPI studies, including summer camp studies and evaluation of outdoor workers. So this discussion question asks us to look specifically at appendices 1 and 2. And my rereading of these appendices basically reinforced my feeling that both present actually a generally good summary of trends, background versus anthropogenic ozone levels, co-pollutant correlations, and especially kind of defining a number of different exposure relevant metrics that are used to characterize ozone in the health effects studies. So I kind of wanted to, in my comments, focus also more narrowly on the discussion point, which deals with the difference between laboratory generated ozone and ozone occurring in ambient atmosphere, and then also how any differences in these in where ozone is measured, or the metrics used to kind of characterize ozone, may actually lead us to differentially weight, or our inability to kind of differentially weight or distinguish between the observational and the controlled studies. So I feel like this was a bit of a leading question, Leanne, but because I think you kind of, in this question, it really does, in my mind, you put your finger on something that I think might be, in my opinion, was missing in the 2020 ISA. Okay, and that is that there really isn't much of what I see as an adequate discussion of these differences, both the differences between lab-generated ozone and ozone in a natural atmosphere or ambient atmosphere, and then also, you know, how that might propagate through the EPI studies or the controlled human exposure studies. Right? So it really does kind of lead to a little bit of confusion, at least in my mind, in being able to make judgments about the differential weighting of those lines of evidence. Okay. And one of the things that, in rereading the 2020 Ozone ISA, and I was not part of the panel that participated in the 2020 ISA, Ozone ISA. But one of the things I noticed is that there wasn't really a dedicated section that deals with modes of action for ozone health effects, which has been included in ISAs for other pollutants. And I felt like that this was actually missing and a really big kind of gap in the science, even though there is certainly discussions about the mechanistic links between exposures in response, both in some of the control studies as well as in the EPI studies that are presented throughout the ISA. I felt like not having a separate dedicated section on ozone modes of action would have been a step, or could be a step, that would allow us to elucidate, some of the charge questions here that are addressed. And maybe this goes, I don't think it necessarily, I did look at the draft PA, and there's, again, it dances around the question of modes of action, mechanisms of action specifically, but it doesn't really appear. So this might be one of those things that for the next round of the ozone ISAs, that's something that EPA may want to consider, or maybe EPA staff has rationale for why it wasn't included now, or maybe they felt that it was, or maybe I missed it. So all possible. And so why is this important? Because I think that in talking about modes of action, it would then allow us in turn to really differentiate how chemical composition and subsequent kind of biochemical or biophysical response may differ between, say, a controlled exposure study that has what people might think of as pure ozone versus ozone that's measured in an ambient pollutant mixture with other phytoxidants. To me, at least, that would have been a good first step to address that discussion point question. And then my second point on this specific issue, which is admittedly pretty related to the modes of action thing, is that so Appendix 2 does do a really good job of laying out a range of exposure metrics that are used in health effects studies, and defines both the strengths and weaknesses of these respective metrics, what the potential errors that we might observe when using these different metrics, in health effects models. But exposure assignment in controlled exposure settings is actually, to me, noticeably neglected. So how in a controlled exposure setting, is ozone exposure assigned? It might be self-evident, or so self-evident that that's why they didn't include it. But that, to me, again, should be another alternative metric for exposure that's used in health effects studies that would allow us in turn to be able to directly address and the question of differential weighting of health effects results from the various study designs. So, it's almost as if controlled human exposure studies are like, they exist off to the side, and they have been given their weights because, of course, they're not assessed. The metrics used in those types of studies aren't really, treated the same way that the EPI or observational study design metrics are treated. I hope that's clear. I have, my written comments include all this stuff. So if I'm not clear enough, I hope that what I wrote is clear. I think that one of the issues, obviously, that might differentiate lab generated ozone exposures from those ambient ozone is obviously that ambient ozone occurs in a pretty complex mixture, and this is like an oft-repeated refrain that we hear with the other ISAs, and I've also expressed this previously too. But again, it's in rereading the 2020 ISA, I think that how EPA treats the issue of potential copollutant confounding still, to me, is slightly problematic. But I do really appreciate that EPA staff, and also expressed in this ISA, I see it like a lot of effort, being directed towards this specific question, because it rightly is one that is it's not important, but it also has the potential. It is important in its own right, but and has the potential to kind of really introduce bias and uncertainty into the science. So what do I mean? I think that here in the 2020 ISA, and I'll just try to kind of basically just summarize my written comments pretty concisely here. It's that there still continues to be this over-reliance on multi-pollutant modeling as the, almost as the most important or sole means of controlling for potential confounding, which I don't think that that's the case. And I think that, we see actually with other ISAs that there is a movement to look at other more sophisticated or newer, more modern approaches for addressing confounding, whether they be causal models, and I have actually more extensive comments in my other set of written comments that I guess we'll discuss tomorrow or on Wednesday. But what I think happens then is that because of the way that EPA does kind of look to these multi-pollutant models and the results from the multi-pollutant models versus the single pollutant models, and comments such as I have one in my written comments that basically downplay the potential because the correlations tend to be low between ambient ozone and other co-pollutants, that it doesn't seem to be an issue. It gives, I think, a somewhat of a false impression that the observational studies, the EPI actually is truly looking at ozone in a vacuum, similar to a laboratory generated study. And that is not the case. I mean, I think that even though there is certainly a role for the multi-pollutant models in terms of both assessing the potential for confounding, effect measure modification in some cases, and for controlling for other co-pollutant exposures, I think we all should accept the fact that those models are telling us something about health effects in the presence of residual confounding. And, I just think that that's not necessarily the impression that one would get from reading the ISA on this specific issue. Okay. And again, these are issues that relate and pertain to topics that we'll discuss, on Wednesday. So I don't want to, I'm just going to leave it at that. And then just my last point with regard to this question charge was about the role of the panel. These are, panel studies, the summer camp studies, and other studies of outdoor workers and ozone. I think here too, there is better treatment in appendices 3 and 4 that look specifically at short-term exposure and acute health response. There really isn't much discussion about the panel designs themselves, other than to say that that they likely contain lots of error in terms of the exposure metrics that are used, and we can kind of discuss that. So it talks about them in the context of measurement error in this panel design. I don't really want to go too much into that, but definitely, I'm not sure that I can say too much from the information presented in this appendix to that question about the summer camp studies and outdoor workers beyond that. So I'm going to stop talking. My colleagues have really good comments that they submitted to on this discussion point right now.
All right, thank you, Jeremy. Let's see, next up is Ed Avall.
Thank you. So I'll just add a couple of comments to Jeremy's, whose comments I generally wholeheartedly endorse and agree with. I mean, I think, for me, I tried to keep a line drawn here between the exposure assessment sort of direction of this line of questioning today and the health evidence for Wednesday. So I sort of thought about this in the context of generation and monitoring as being the questions to face here, and how that comes into the issues related to either controlled human exposure studies or field studies and outdoor examinations. And I think, many of my colleagues here on the panel have had a lot to say about the differences and the potential concerns related to how one infers effects of information from controlled chamber studies and the actual outdoor human investigations. I think, again, in the chamber, having spent, a good part of my career both in chamber work and then out in the field, doing both, I can sort of speak personally to these things. And I think, it is dramatically different. I mean, I think the measurements, in the chambers where we try very hard, we work with as highly filtered air as we can. We generate ozone in a clear form as we can, monitor it in that sense. And outside, as Jeremy pointed out, there are so many things. Multi-pollutant sort of emphasizes the complexity of what people are exposed to outside, not only ozone. I think we need to keep in mind that ozone is a marker under the Clean Air Act for ozone and other photochemical oxidants. That does not say that outside you are not exposed to other things, or that outside those multi-pollutant effects are not impacting those ozone measurements. And I think that, personally speaking, growing up as a child in Los Angeles, the years of growing up with, eye burning irritation and chest burning irritation from breathing outdoors, not only ozone, but the other photochemical oxidants, I think is something that is sort of, for no pun intended, but sort of burned into my brain as thinking about these things forever in terms of understanding the health. And yet in the chambers, when we generate ozone, I think that is a different sort of thing. And that raises the concerns that, the way the information is used, and again, as we'll talk about on Wednesday, how in some ways I personally think the overemphasis on the chamber studies compared to the field studies, I think that in a sense sells short what we see, what we observe, what we sort of know to be the case in practical experience outdoors with all these pollutants. And although I am, I guess, inspired, impressed, I appreciate all the efforts that the agency has gone to try and understand multi-pollutant confounding in the document. I do think that there still is some room that, some acknowledgement, some assessment, some practical assignment of this in the context of taking the chambers data and then trying to put it on a par and draw conclusions from it with the field ambient sort of real exposures, if you will. I think the inside chambers studies are quite different, starting just from an engineering mechanistic standpoint in terms of how we work hard to sort of minimize reactive surfaces, maintain stable concentrations, all the things that don't happen in the real world, where you have carpets and, fleecy coverings and vegetation surfaces and, all these things that change the actual delivered personal exposure outside. So I think it is a different consideration. And I think that we haven't quite captured that and valued that appropriately in going forward to adjust the information. Again, I do think, having spent some amount of research time in both areas, I think both of these elements, controlled chamber studies and field studies, provide invaluable, critically important evidence. But I think they're complementary evidence. They're not overwhelmingly independently important to the denial of the other. I think toxicology, of course, is the third leg in the stool that adds to this, but I think they each have their strengths. They also have their weaknesses. And I think we need to be mindful of how we balance those and trying to get a composite picture. So I think of it more as a sort of a Venn diagram with overlapping benefits, but not completely uniformly overlapping, so that there's just one oval there, I guess, on the visionary plot that you think of in terms of what the benefits are. I think they provide beneficial information, but different kinds, both with shortcomings and strengths. And maybe I'll stop there. So thank you.
All right, thank you, Ed. Let's see, next up is George.
All right, thank you. I think Ed and I are more or less on the same wavelength here. And I do think it's really important that we're discussing this in detail. I think there's a lot here that has been missing in previous reviews on this discussion topic. I brought it up back in 2011, but it didn't get traction, so I dropped it. But here we are. And this is important in terms of the causality determinations, which does drive what gets attention in the PA. So, as Ed said, I think there is value in assessing effects on healthy adults in the absence of any confounding pollutants, controlled human exposure studies. But I don't think this approach should be used to support reduced confidence in short or long-term ozone, cardiovascular, or mortality endpoints in the general population, free-ranging humans exposed to the real thing. And as Ed pointed out, that the NACS is for ozone as the indicator for ozone and photochemical oxidants. That is critically important. It is not it's not all ozone, which is what chamber studies do. It's just ozone. It's all this other stuff, the photochemical soup that's out there that comes along with ozone. That's primarily PAN and hydroxy radicals. These are not benign substances, and they can do things. So that's the point here, is that if you base your causality determinations on the indicator as opposed to the complete package that humans get exposed to in ambient air, that could be that could produce some biases towards no effects. In practice, the reality is these non-ozone oxidants, that part of the package is the photochemical soup package. They've been pretty much ignored because they are more difficult to quantitatively measure. You can kind of sort of do it. You can certainly do it for PAN and OH radicals, but the whole package gets a little complicated. But that doesn't mean they're not important. And we had a teaser from the Moses 2 study where they didn't see anything in their chamber work, but they did see reduced HRV in their 4-day pre-test ambient exposures. So that sort of reinforces the concept that ambient ozone may behave differently in terms of some of these cardiovascular endpoints than pure ozone in the chamber. And for what it's worth, a recent review actually just came out last week, and a meta-analysis of studies on short-term exposures for ozone and HRV that used ambient exposures as the metric came out, Zhang et al., and the reference to that is in my individual comments for those that want to look at it. I think it's really fairly well done, but I'm not the best judge of that, so I'd be interested to see if others think that is a useful review and meta-analysis of that. And finally, I want to point out an interesting parallel on this topic to what we did with PM. Some of you may recall starting 15, maybe 20 years ago, the concept of CAPS, which is concentrated ambient particles, CAPS PM, where we would concentrate real ambient PM using virtual impactor technologies and use that for controlled exposure studies. And what came out of that was, it was pretty readily shown that there were cardiovascular effects consistent with the PM mortality epidemiology with these exposures to the real thing. But when you used lab-generated PM of individual species, ammonium sulfate or whatever you want to choose, did not usually show that. So that's to me an analogy of the importance of the synthetic lab stuff versus what's out there, which is what we're talking about. So, I am concerned that using just ozone, only ozone, to assess the short-term health effects of ambient ozone, where ozone is the indicator. They may underestimate health effects and possibly miss cardiovascular effects. And in that sense, then, I think that the weighting of health effects evidence from the controlled human exposure studies should reflect these limitations. I don't think it was addressed at all in the ISA. And just as importantly, the lack of evidence for cardiovascular effects in these controlled human exposure studies should not be used to discount evidence of short or long-term cardiovascular or mortality effects in the general population that is exposed to the mixture of ambient photochemical oxidants that is of concern here. So I think that's it for me. Thanks.
Thank you, Ed. Let's see. Last up is Rick Peltier.
Great. I won't echo what my colleagues have said. I agree with them up and down, pretty much on every point. I ultimately kind of agree that the document is written, the ISA is written, doesn't provide a lot of guidance for EPA to delineate the substantial differences between controlled exposures and the epi and observational data that we see. Some of the data, particularly in Appendix 1 on the atmospheric chemistry side, needed further development, at least from my viewpoint. I noticed and noted a sustained increase in petrochemical and industrial precursor emissions of VOCs. And while that's just purely an emissions issue, this is also the precursor that are located where people live. So if you're interested in protecting susceptible populations, you look for those anthropogenic emissions first. There's more control that we have potentially available that would pay more dividends if we were able to keep them lower. So if you're interested in looking at susceptible populations, you look at where the exposures are the highest, and those are likely to be where these precursor emissions are being released. I think the other issue that I would raise, and Jeremy kind of danced around this a little bit, is that there is a copious discussion of the different types of studies that are out there, primarily epidemiology, talking about the flaws, the strengths and weaknesses of each mainly epidemiologic approach. And then there was almost no discussion of controlled studies and some of the flaws and weaknesses. And I think the problem I have that this the way this lays it out for EPA is that the EPI studies all come with some sort of flaw. None of it is inaccurate. It's all true. And then there's essentially silence on controlled human exposure studies. And there's an implication there that CHE might be in some way superior to an epidemiology study, which has well-documented weaknesses. And so my fear is that sets up an opportunity for a bias towards a controlled study. They're both very valued studies, but they're both very different studies that are designed to test very different hypotheses. And so I think if you can make one look ugly and the other one look beautiful, that's an easy way to kind of spin which science you accept and which ones you don't, or at least discount or weight them differently. And I think that's really all I would add to my colleagues. Again, I agree with what everybody has said so far, and I'll leave it at that.
Okay, thank you to everyone on that group. Is there Terry?
Yeah, I really agree with what Ed and Rick and George and Jeremy said. But I want to take it a little further. First is a little nerdy question. If as said, if we put so much emphasis on these pure, well-designed, controlled human exposure studies, does the Appendix 2 question how that ozone is generated? As Michael and Mark and others know, what your source gas is really affects what comes out. If you're using a high voltage spark generator and you're using regular air, you're going to get some NO type species coming out of there. So I was just curious if it mentioned it. Then flipping which George started hinting at. So I agree with George, and ozone as an indicator is important. I also wonder why so much emphasis is put on the controlled human exposure studies as opposed to the EPI studies. Usually I look at controlled human exposures as supplementive to the EPI studies. So the flip I wanted to ask is, when EPA chooses the relevant regions in their PICOS criteria, it flips all over the place. Sometimes it's just North America and Canada, sometimes North America, Canada, and Europe and Australia, sometimes Australia is not included. So if as George said, if ozone is ozone, it's a pure chemical, and of course there's other oxidant species, but why is EPA changing from one health endpoint to the other, whether it's short-term or long-term, and leaving out certain regions? There's a ton of China studies in Asia that are included, especially in the more recent literature, as Leanne asked us to look at. And I was just wondering why EPA has changed from one spot to the other is important and relevant as far as the NAAQS consideration.
All right, thank you for that. Is there anyone from EPA that wants to answer that now? I'm sure it'll come up again to some degree tomorrow or Wednesday. So if you want to wait to answer on Wednesday, we'll probably come back to it. I'm sure, Terry, you will ask that question again.
Yeah, and I guess there was nothing I saw in the ISA that directly said why certain regions or countries were included in this health effect and not in other health effects. They might want to wait to answer that.
So I see Steve has his video on, so go ahead.
Sure. This is Steve. I'll just mention that we'll have a few more of our health effects experts on Wednesday, so we could definitely circle back and address that. It is, as Tom Lubin mentioned, I guess it was a couple weeks ago in our previous call. It's a combination of factors that go into deciding what the scope of the ISA will be, including availability of evidence. In some endpoints we have an abundance of evidence that's relevant to current ambient concentrations that we see in the US, and in other situations we don't have that same abundance. But it's certainly something that we could dive into more detail on Wednesday.
Yeah, I absolutely think this is an important topic, so we should come back to it. And so Terry, will you help me make sure that we bring that back up again on Wednesday when there's more EPA people here? And Jeremy, you wanted to chime in.
Yeah, not on this last topic, but to Terry's other questions about whether or not Appendix 2 included a discussion about the ozone generating processes that are used in the studies. I didn't see any, but that would be interesting to see for sure. And then, I mean, just to kind of reiterate one point here about, the differential weighting, or why it does appear that in the health effects sections that there does seem to be undue or a little bit greater weighting to the controlled exposure lines of evidence. I mean, I understand it. I completely understand it, because the EPI in many cases is equivocal. And it's equivocal because it's really complex, and the exposures are occurring in what we all can kind of acknowledge as these really difficult to characterize mixtures. So we don't see results that are as consistent, perhaps, as we do and all this is also to say, one of George's comments too, that that we'll hopefully have a chance to kind of come back on Wednesday, which is that in spite of the uncertainties and the equivocality and all that kind of stuff, I don't believe that it does really weaken, causal determinations that have been arrived at in the ISA. It's just something that's missing right now. Yeah. Anyhow, that's all I'll say.
So when you say you don't believe it weakens the causal determinations, are you talking about controlled human exposure studies?
I don't believe the fact that there's no discussion on the differential weighting necessarily weakens the causal determination. I mean, I think actually I should probably clarify for many of the exposure outcome pairs. I think that there is a question that we'll, I'm sure, discuss with regard to the cardiovascular endpoints in particular, but I do believe that there is a lot of evidence that certainly does strengthen some of the causal determination from the observational studies, even though there is, it is hard to characterize, what exposures we're looking at, and it is hard to control for potential confounding, and there's most likely residual confounding. But despite that, I think that those lines of evidence, to me at least, are persuasive in strengthening causal determination for many of the exposure outcome pairs. So anyhow, that's what I meant by that. Thanks for making me clarify, Leanne, because that could have been misperceived. What I said.
Yeah, thanks. 'Cause I hadn't captured what you were intending. So Michael, you're next.
Thank you. I just wanted to add a couple of other ramifications to the controlled studies. And one of them is that in general, the controlled studies use relatively healthy individuals for obvious reasons. And whereas the field studies and epidemiological studies tend to use a broader spectrum of people exposed in the real world. And when you take out some of the other pollutants in Appendix 1, I think the other photochemical reactions, I think, are presented in one sentence, and they're named, but there was no discussion of what their possible addition to the health effect might be if they were present, which they're not in the, as already been mentioned, that's not present in the controlled human exposures. So, when you look at the dose response function that comes out of controlled human exposures, it's really, a minimal thing compared to what, to the ozone plus photochemical oxidants might have in the real world. And I think it really does lend a little bit more strength, or maybe a lot more strength, to the importance of the epidemiological studies, even though they have many drawbacks. What you get out of them, especially when you start looking at the response to ozone as a function of dose, I think it really should not be undercut. Thank you.
Okay, thank you. George.
Just echo a couple of comments, what Mike just said. There's two issues with the controlled exposure studies. One is it's just ozone, not all the other stuff. And the other is, as he noted, it's healthy, non-elderly subjects. And a lot of the EPI, especially the ones that look at Medicare cohorts, they're not young. They tend to be elderly. They're on Medicare. So you've got a couple of factors there that are, when it comes to looking at cardiovascular endpoints and indicators, you've got a couple of potentially very large components there that are attenuating those endpoints in the controlled human exposure studies. And also, I just, on what Terry said, in terms of how you generate the ozone, if you're using spark discharge, that's a really bad idea for a lot of reasons. I would hope, and I don't know if it's detailed in methods, but I would hope they're using UV light radiation to generate the ozone. That generates a very, very, quote, clean ozone, if that's a term. That would be appropriate, but that's worth seeing if study methods cover that. Thanks.
Okay, thank you. And before Jim, just a second, the third comment about controlled human exposure studies is also a feature of toxicology studies, is because of their cost, they can't be very big. So the kinds of rare events that we can look at in epi studies, you can't, there's just not enough participants to even look at them. Go ahead, Jim.
All right, so I have one comment and one question. So my comment is related to the co-pollutants for the EPI studies. You know, the chapter 2 does a good job of talking about carbon monoxide, SO2, NO2, PM10, and PM2.5. It does make a statement that co-pollutant correlations are higher during the warmer seasons. Greater risk of co-pollutant confounding exists. And so obviously the warmer season is when you're going to have the highest ozone concentrations and the highest ozone exposure. And in fact, when you looked at the summer, it showed PM2.5 as being the most correlated. You know, and PM2.5, you know, has important health impacts, and some of the health impacts are similar to ozone. So just something to keep in mind. And then the part that was not included was any discussion on co-pollutants with hazardous air pollutants, such as benzene, formaldehyde, acetaldehyde, acrolein, and many others, which have short-term health impacts as well as long-term health impacts. And many of these pollutants are associated with the same sources that are emitting ozone precursors, such as mobile sources, industrial sources, and biogenic sources. So the fact that that is not taken into account, you know, increases the uncertainty. And, you know, that might be something I would recommend for future research, is to actually look at the non-criteria pollutants, especially the hazardous air pollutants, and see the co-pollutant correlations. And then my question was, so that was a comment. My question is there, and this is kind of open for everyone, because I'm not familiar with, you know, we talked about the other oxidants besides ozone, and, you know, I didn't see it in the document, you know, the relative impacts of these other oxidants versus ozone. You know, if you go out to the real world, is, you know, ozone only half of the impact, 50%, and then the other, you know, the other 50% is these other oxidants? Or are we talking, you know, 1%, 2%, 5%? You know, and the answer to that question will help us understand, you know, how different the human exposure studies are from the real world. And I guess I'm not familiar with the relative percentages. So if anybody else on the panel has any insight on that to help me understand that, I would appreciate it. Thank you.
All right, thanks. I see several hands up. Should we try, is there anybody who wants to address Jim's question directly before I just move to the next person? In which case, just speak, please.
I can address it indirectly, maybe. I don't have a good answer, but the answer I do have is back in 1971, the original indicator was total photochemical oxidants. And then in 1979, that was changed to ozone. And the NACs went from 0.08 ppm when it was total oxidants to 0.12, up by 50%, when they got rid of the other stuff and made it just ozone. So I don't know what the basis for that adjustment was, but that implies, assuming it was a plausible adjustment, that the other stuff is not negligible. You know, it's a significant fraction of the total ambient oxidant burden. I hope that helps.
Well, yeah, I mean, I just kind of just chime in, you know, for direct measurements. I mean, there's been work that's been done over the years looking at like newer measures of, say, oxidative potential in pollutant mixtures, you know, other measures of ability to elicit redox activity. This has been looked at specifically in terms of trying to kind of apportion the relative oxidative potential of, say, SOA versus other forms of organic mixtures in the atmosphere. So, I mean, I think that there is stuff in the scientific literature out there, but I think that would be good also to look at that. It's still not 100% there yet, and there's certainly not a standard way to kind of characterize that function of oxidative activity.
And George, I know you'd mentioned hydroxyl, radical, and pan. I mean, these are things that are not routinely measured. Is that correct?
That is correct. And maybe that's a future research need. I mean, I haven't looked closely at the literature, and others can correct me, but and by and large, I think it's been pretty much ignored.
Well,
certainly
some of the species don't exist for very long in the
well,
atmosphere.
they're non-trivial to measure. That's part of the problem.
Okay, thank you.
Okay, Ed.
Thank you. And I'm happy to defer this discussion to Wednesday, but since you brought it up, Leanne, I just want to point out that there are several issues that differentiate controlled human exposures from outdoor epidemiological sources, not the least of which is sort of what I might consider one of the holy grails, which is the issue of peak versus long-term low-level exposures and how those are quantified and what relative importance those have. And obviously, one is more amenable to chamber studies, the other more amenable to real-life exposures. So it can get complicated. There are many other issues that differentiate them. I suspect Christine is going to make comment about at least some of them. So I'll stop there.
Yeah, and even though I couldn't hold back in making a comment too, we probably should defer most of this discussion until Wednesday because we need to dig into it thoroughly. That said, I don't want to cut you off, Christina, if that was what you wanted to say.
No, I mean, I think some of these, I just wanted to agree with some of the points that were made thus far and some that will be expanded upon on Wednesday and Friday. But just in particular, when Jeremy raised the issue about the scavenging of pollutants near roadways, the scavenging of ozone. And I think there needs to be more explanation about that in the ISA because the way it's written, it seems like that's not very important or it's not very impactful, but there are actually millions of people that live or work in those areas close to highways where the ozone is going to be different from that central monitor, even though overall there's not a lot of variation. But I think that needs a little bit more attention to bring that up, is that that is a relevant thing, that scavenging near roadways. And also I agree with Rick in terms of there not being much attention paid to the analysis of the shortcomings of the controlled human exposure studies. And that's definitely something that can be included so that they can be weighed more equally with the other types of studies. So I'll keep it at that.
Thank you. So anyone else have any comments on this topic? So circle back to Jeremy. Do you feel like you have what you need to lead up the write-up of this topic?
Yeah, a lot of really good insights and actually a fair amount of consensus. So I think I do.
Okay, and that is the last item on our agenda for today, and it's a little bit quick turnaround. Oh, I see Steve has his hand up. Before I'm not going to close the meeting yet. So
yeah, actually, sorry, I did want to. I was trying to get my hand up and couldn't get it up in time, but I did just want to circle back on one really quick comment that Jeremy made at the very beginning of this very helpful discussion. And that was the comment about the lack of the mode of action discussions in the ISAs. And I'll just mention that's in there. And actually, this is another thing that we can discuss further on Wednesday because we intentionally moved it in closer with the health, the individual health effects, health endpoints in the health appendices that we'll discuss on Wednesday. So you'll see each of the major appendices starts out with what we now refer to as the biological plausibility section, and that's where we've pulled that in. And that was a change we actually made on the 2019 PM ISA, and we incorporated it into the 2020 Ozone ISA to get that that kind of biological plausibility in closer to the actual endpoint that we're looking at.
Yeah, and thanks, Steve. Yeah, and I did notice that too in reading the health effects sections. That certainly I didn't mean to imply that the ISA was devoid of any discussions of biological mechanisms or plausibility. I think that for the purpose of informing this specific question that we were given about the differential weighting and stuff like that, it would have been maybe good to have a dedicated separate section, but I hear what you're saying. Yeah, thanks for clarifying my comment.
Great, thank you.
Okay, now I think we're ended with that topic. And Aaron just sent a note to the people who are in charge of Appendix 1. And the question we have, since it's quite early, much earlier than we were planning for ending today, are the people who are assigned to Appendix 1, that would be Jim Boylan, George Allen, Judy Chow, and Jason West. Are you all available and able to talk about that topic today? I'm trying to remember, wasn't Jason going to be out some of the time? So he may not, is he in the meeting right now?
Leon, I'm here, but I haven't, I'm not ready to speak about that topic. But if you wanted to get opinions from the others, that would be fine.
Okay. Yeah, sorry about we're just blazing through this agenda. So it seemed like maybe we could cut our meeting short on Friday. By covering this topic, others have thoughts? You want to wait till Friday, or you want to say something now and we can circle back and get additional input on Friday? What's your preference? Jim, I'm going to let you, since you're the lead discussant, I'm going to actually let you make that call if you would like.
So I don't actually, I have my notes, and I don't have a whole lot to say on it. So I mean, I could go either way in that, you know, we could do it today and then have follow up on Friday to kind of make it quicker, or just hold it to Friday. And so I'm good either way. I don't know if the others, you know, who else was, who did, let's see, we had.
Either way works for me. I can do it now or then.
And then there's Judy too. Is that okay with you, Judy?
Yeah, I'm okay. We can go ahead and discuss today.
So I'm suggesting that maybe we do that, and out of respect for Jason not being ready and as being for Friday, I get that. We will come back to this topic and make sure that anything that's relevant comes up. And it seemed to me there were a couple of things that came up in our recent discussion that might be relevant to this this topic as well. So do you all want should we take a quick break so you can get ready? How about we just take a couple of minutes? How about we'll just take a 2-minute break and then we'll come back at 10:25. All right, that was short. Is the group back and ready to go? Jim, do you ready to start?
Yep, I'll jump into it. I just have a couple of points to make here. So I'll start out with my initial comments. So the 2020 ISA contains information that was available at the time. So, you know, keep in mind, this document came out a couple of years ago. And so that's why the 2014 NEI inventory is in there, and the ambient air quality concentrations and the trends data is only through 2017. More recent information on precursor source emissions and atmospheric ozone concentration trends were presented in the 2020 policy assessment, as well as the April 2022 draft policy assessment, which actually includes precursor emissions from EPA's 2017 NEI, which was released last year. It has 2018 to 2020 design values and 2000 to 2020 ozone trends. So although the ISA is kind of a little outdated with some of this information, it is updated in the policy assessment. So I think, to me, that is, to me, covered. And then there's also some new information on background modeling that is actually included in the policy assessment. So when I look at it kind of all together, to me, it covers, does a fairly good job of covering these topics. The one area where I did want to spend a couple of minutes talking about was wildfires and exceptional events. And I know that, whether exceptional events should be included or not included in design value calculations, that's more of a policy discussion. It's also maybe even more of an implementation discussion rather than even a NAC setting discussion. But the one piece I did want to talk about was actually how exceptional events would actually fit into the ISA document. So EPA allows exclusion of high ozone concentrations due to wildfires under the exceptional events rule when calculating ozone design values. It is important for epidemiological studies to include any ozone concentrations that were excluded due to exceptional events in their study, and not use the official design value with the high ozone values removed, so that any potential associations are not biased towards lower ozone concentrations. And a very simple example is, if there were 3 different fire events that produced high ozone, it resulted in a large number of people going to the hospital. If the high ozone concentrations are now removed due to exceptional events, the ozone design value could change, say, from 85 ppb down to 65 ppb, because now you've removed these 3 high events. If the official design value is used in the data analysis, it will incorrectly associate those hospital visits with an ozone design value of 65 ppb when they are actually associated with an ozone design value of 85 ppb. So in summary, EPI studies that exclude exceptional events from the exposure estimate, but include the health impacts associated with those events, should not be included in the ISA. So that's summary of my comments.
Thank you. And I had a little bit of a follow-up question on that, because since the ISA, the purpose of the ISA is to review the scientific evidence, and Appendix 1 goes into the atmospheric sources and trends and so on. Do we have an opinion on whether that scientific review should just never exclude exceptional events, or maybe do it both ways so we can understand the impact? I hear what you're saying about the policy aspect of the exceptional events, but I guess since our review is of the ISA, wouldn't our understanding of the science be better informed to include those, or to look at them both ways?
Well, so I think you want, when you're doing the correlating the health impacts with the ozone concentrations, you want to have an apples to apples comparison. And to me, it's not fair to have a bunch of hospital visits and count that in your health impacts and then throw out the high ozone data. And when you throw out the high ozone data, now you're correlating those hospital impacts with a lower ozone value, which really isn't appropriate. So, I mean, I do think it might be good to look at it both ways, which would allow you to maybe see, how prevalent these exceptional events are and things like that. But to me, when you're doing the EPI studies and you're correlating health endpoints with, say, design values, if those design values have thrown out a bunch of high ozone days, but those high ozone days are still there and people are still being impacted and having health impacts and going to the hospital, to me, it's just an inconsistency. So that's just my thought on that, you should include those high ozone days when you're doing your EPI studies. Like we also said, it would be nice to see how prevalent they are, how frequent they occur, but to basically throw out high ozone values and still account for the health impacts, to me, just doesn't seem appropriate.
Yeah, and I don't think the EPI studies do exclude high exposure days. So I was asking more about the summaries that were in Appendix 1.
Well, I guess one comment is, it's hard to know, if you look up design values from EPA, you got to do a lot of digging to figure out what data went into that design value. And if an EPI study just pulls a design value table, from an EPA report, they're going to have no idea if data has been excluded or excluded. And I haven't looked at any of the studies. I don't know how much this occurs or not. In Georgia, I know we haven't had any exceptional events. We don't have any. So if you're using Georgia data, this is not an issue, but out in California or out in the West, this could be a very important issue.
All right, thank you. Michael, you had your hand up.
Yeah, thanks. I just wanted to point out that this could also add to, when you're starting to look at causality, uncertainty in attributing causality, because if you have studies where the design value is used without adjustment for the exceptional numbers, and let's say arbitrarily that comes out to 0.65, and then you see a significant health effect on certain days, then you look at another study that is looking at a legitimate 0.65 without exceptions, and you see no health effect. That adds to a lot of uncertainty, because here you've got one study that's positive and one study that's negative. And excuse me, when those are factored into how do you attribute causality, this comes out as equivocal results when you add them all together. So I agree. I think you're right, Leanne. Most good EPI studies take all this into account properly, but there are studies that just as Jim mentioned, pull the data from an EPA website without further looking.
All right, thank you. Let's move on to George.
All right, I don't have a lot to add, actually. Looking at my written comments, I think they strayed more into the policy assessment than the scientific assessment, but let me see if I can go through them in that sense. And to address the question of what do EPI studies use, I think they use, they usually mine the EPA database. So if an exceptional event for ozone has been removed, I think we had this discussion in the PM review. There are usually, even though exceptional events may be removed for design value calcs, I think the data are still in AQS. They're still in that database. And Jim can confirm or deny that.
Yeah, I believe they still are. And like you pointed out, it's just a matter of knowing where to go and actually dig into the numbers.
Right. So I would hope, and I would expect that, you know, the studies, the large studies that use data from AQS, and then maybe they, you know, they model it and massage it and, you know, do all that other stuff would include, you know, all the valid measurements regardless of what causes them. Now they may throw out the top 10 and bottom 10% as extreme values when they do an analysis. That is often common practice, but that's a different discussion. So let's see, on Appendix 1, specifically on wildfires and exceptional events. Absolutely, wildfires are, you know, becoming, as with PM, this sounds, I'm getting deja vu here with the PM review. They're becoming much more prominent. And I'm afraid they're probably going to remain that way for the future. And they are a large source of ozone precursors. There's some NOx in there, but there's a lot of VOCs. And I think the conventional wisdom is that when you take a VOC-rich plume and you transport it across an area with an urban area with lots of NOx, or maybe a point source of NOx plume, you can get elevated ozone. So this is becoming more important. I won't get into current exceptional event practice. I think those are discussions for the policy assessment, but there are certainly lots of questions there, which if you want to get a preview, you can read my individual comments on this. Background ozone, there's a fair amount of really good analysis in the ISA. I mean, in general, I think the ISA treatment of this appendix is good. It's thorough, and it's relatively uncontroversial. I mean, there's a lot of this is there have been incremental improvements in our understanding of everything. The chemistry has been settled for a while, but background ozone and issues like the wildfires they're still moving a bit. But you know, they make the point that background ozone, what we call now USB, not policy relevant background, what it used to be called. It's primarily modeled because it's really hard to measure. You can't find a location in the US where there's probably not some influence, at least on a longer term basis, of US anthropogenic ozone sources, precursors. So, you know, tools, chemical transport modeling, Geoschem, Chemex, CMAC, they're all used. And I think that is getting better. So why do we do this? I mean, this is maybe a PA topic, but I'll throw it out here just because I'm a little confused. It's my understanding that when we set a NAAQS for ozone, it's based on the health and welfare effects without regard to, in this case, contributions of USB ozone. And that can be considered an implementation, which we don't talk about here, but not in actually, you know, picking a number. So this is really more of a PA thing, but I wanted to throw that out as to make sure I'm on the right side of the concept and the process here. And then the last thing is a bit of an oddball, but we're going to be changing how we measure ozone. And it's actually going to make the reported ozone concentrations go up by 1.2%, starting in sometime after January 2024. What is this, you say? Well, the world has gotten together and decided that the cross-section absorption coefficients that are used for calibration of ozone monitors need to be adjusted. There's a lot of background work on this in several papers. I have a link to the international standards workshop on this topic where it summarizes it and points to all the references. But, in that sense, even if we don't change the NAAQS value, the NAAQS will be tightened by roughly 1 ppb, 0.85 or so ppb, 1.2% of 70. So just an idea. If the EPA lead on this is Joanne Rice at OAQPS. There have been various discussions and presentations on that, but I suspect this is new to this panel. It's small, but not insignificant tweak. This is not in the 2020 ISA because this decision was, arrived at after that was finalized. So I just put that out there for those who are interested in the details. I think that's it for me. Thanks.
Great, thanks. Jim, did you want to chime in about something?
Just a follow-up question, and it might not be for George, but I guess George asked a good question about the USB and its role in setting the NAAQS. And I guess I'm curious, maybe EPA could answer this. Can the NAAQS be set below the USB, or is the USB kind of the lower limit as far as NAAQS setting goes? And if they could share any information, and like George said, that might be more of a policy question, but it helps us kind of understand why we're even looking at background in the ISA. So I don't know if EPA can answer that question.
We may not have the right EPA people on today for that. I don't know.
Yeah. So we can bring it back on Friday if it's
Yeah.
or Wednesday.
Yeah, we'll be coming back to this topic on Friday. So I see there's Steve McDowell from EPA is there. So
yeah,
chime in.
I can just say that's more of an OAQPS question.
So as in policy assessment?
Yeah.
Yeah.
I agree. Just going forward, it might be helpful to have an answer, clarification on that earlier on in the process.
Yeah, so if maybe we can just ask for EPA to help us answer that question on Friday, that would be helpful, just so we can factor that into our thinking. And we will be coming back to this topic anyway. So, Judy, I think you're up next.
Okay. My discussion follows several things. One is the emission trends. So thank you for Jim to clarify that the differences between the the different time period. So we have 2014 National Emission Inventory for the ISA, whereas PA used 2017 NEI. That one issue is that I see there's some more detailed information, even with the 2014 ISA in terms of ozone precursor emission trends in the figure 1.2. That show up and down fluctuate Wi-Fi emissions for CO and the VOC. However, it only give us the period of 2000 to 2014. And that they stopped there about 8 years ago. So as frequency intensity, and I've already discussed so far, the Wi-Fi has increased since 2015. So we really like to see an updated emission trend that reflect more recent fire emissions. So what I'm saying is, even with 2014 NEI, they did not cover the period of that the trend. And another thing is make it more difficult to compare is that we do know that seems like VOC and CO has been increased, and source types between the 2020 ISA and the 2022 PA are different. So Wi-Fi kind of disappear in PA and lumped to the other categories. So it make a comparison really difficult between those, even between two NEI. So that's with respect to emission trends, because I would like to see EPA give us emission trends for the wildfire emissions for CO and the VOC. And many people have been commenting on the wildfires and exceptional events. It's interesting that when I dig back, the exceptional event rule was promulgated actually in 2007. I guess it wasn't be as an issue except for the recent decade of a wildfire. That it is true that just in that recent publication shows that an increasing number of applications for the high ozone layer has been designated as the exceptional event in recent decades. So that so I felt that maybe that EPA, ISA need to clarify how exceptional event may bias the exposure assessment, although people believe that they are included. As Jim says, it's not an easy way to find out which one is the exceptional event. Do they really include it in? So I felt that since the 2007, the exception event rule that tried to eliminate those high concentration, but that never really reduce the fires or protect the public. So maybe EPA should revisit this exceptional event with a goal to adequately protect public health and the environment, and may ask for state, local, tribal agency to work with the U.S. Forest Service, Bureau of Land Management to improve the land management and minimize human activity-induced fire episode. Although this fire could be a PA issue rather than a ISA issue, but they just that it's good to give some thought on that. The next category in terms of ambient air ozone concentrations. Jim is right that they do have a train and they do update it in the PA. There's 1,300 federal, state, local, and tribal ozone monitors. And however, there are very few year-round ozone measurement as compared to the warm season monitoring. I'm pointing out that the state of Washington and the Oregon, that they only monitor ozone May through September. And Leon can tell us if they actually do have fires in early spring or late fall. What does that mean? They actually just missed really some of the exposure period and not adequately being protected. So I felt that since some of the RSA did show that elevated ozone may occur during winter time, then even in Reno, that when the snow covered, we do have a high ozone. So year-round ozone monitoring is desirable. I think that it should be considered because the instruments there and the added effort is not that should not be that big. So that so only monitoring May through September just seemed to be really limited to for us to do a better assessment or look at the annual trend, especially emission variable and the maximum temperature are both from the literature that they actually affect the ozone peak concentrations. And that it's interesting, George mentioned this absorption of cross-section ozone measurement. Maybe EPA can think ahead. And I don't know how that can affect our train. Well, in certain that different measurement will give you what, George, 23% increase?
Oh, no, 1.2%.
1.2 is not too bad.
It's small.
Yeah, it's not too bad. But it's interesting that there's a global effort to unify or standardize the ozone measurement. I think something is important to be in consideration that when we're changing the method in a year or so. At least probably should, and I remember the ISA just mentioned that didn't really elaborate on the potential impact or changes of the method changes. That probably a pretty big issue, especially is on the increasing upper trend. The final category is the background ozone concentrations. And recent improvement in the regional and the hemisphere modeling methods estimate US background ozone levels. And their estimate is 20 to 50 ppb with a 10 ppb uncertainties for seasonal average concentrations. Those estimates seem to be on the lower side. And this, since some sources for ozone on high ozone event probably deserve a little bit discussion on large scale transport process along with the wildfire and the stratospheric ozone intrusion. Now, those may impact the air quality, especially in the southwestern states. And that the Las Vegas study shows about 80% or something the days that have a characterized elevated ozone downmixing event. So it's very unfortunate. George mentioned earlier the pain and the OH radical. None of this is really being measured. And intensive studies such as that one in Las Vegas they did in 2017 rarely happens. And one of the issues is a catch-22 situation. If we don't have a revised NEX, there's not going to be now research funding, there's not going to be any studies, there's not going to be any more of those vertical measurement or intensive studies. So that's partially the reason the ozone NEX has been not been revised for so many years that so it's less research has been conducted. So yeah, it is true that implication of the U.S. background ozone concentration and NEX attainment really need to be examined for the relevant regions. In my write-up, I point out there's quite a bit differences in terms of the nonlinear ozone trend. They increase and decrease over the years. And also, it is true, George said it's difficult to separate the modeling of U.S. background concentration with respect to the baseline ozone concentration. But I point out several of the study of the Parrish group and others, they demonstrate the value of using long-term measurements at isolated mid-altitude sites to better understand the temporal spatial variability of the baseline ozone distribution and the potential impact on the ozone NEX. So especially this is especially important in different regions, especially in the Intermountain West. That's it.
Sorry, I was muted. Thank you. Jason, you're next. Do you want to say anything today or would you like to wait until Friday?
Yeah, I'm going to hold off until I read it carefully.
Sure, no problem. Are there, Ed, I see you have your hand up.
Yeah, I just wanted to make a comment regarding as we move into the Friday discussions on exceptional events and wildfires and ozone. Given what Judy pointed out, I think, there's a sort of a synergy here that the agency ought to consider. And that is that, what we're seeing is that wildfire season has sort of expanded. And many would argue that it's, if at the very least, it's months longer, and perhaps it's potentially a year-round event now, which gets at the question of how exceptional that might be. So that might be a consideration. But the other issue here that is one that Judy raised, which is, for those areas that only monitor ozone from May to September, as we have these increasing wildfire events other times of the year, we are broadening when those downwind formation of additional ozone occurs, and those may change the calculus that has been the case heretofore, that there's no reason to monitor ozone outside of May to September because there typically are much lower levels then. So I think, putting those things together may give a different perspective on why and when we monitor and what that monitoring, another justification for why we ought to expand that May to September monitoring. Thank you.
All right, thank you. Terry.
Yeah, I guess I want you to repeat the guidance. Sometimes it seems a discussion is going to criticizing the ISA and pointing out its deficiencies, but that's not what we're supposed to do, is it? We're supposed to talk about the ISA and how this ISA affects the PA. Like what Ed just brought up made it more clear why the wildfires, the exceptions, is important, at least in considerations of enacts and the PA. I guess I'm getting lost because we're acting like scientists here.
Well, I think we are scientists, so it's hard for us not to act like them. And you know, we can't change the ISA, so I guess the lens through which we are criticizing the ISA is more about both the policy assessment, but also future ISAs as well as future research. And so I think those are reasons why, and maybe it's hard when we're talking about some of these things to quite parse what aspects of the thought are about future research or future ISAs and what are just things that should be improved in this current ISA, which is not going to happen. So I think it's a little bit, we're in our uncharted territory. So some of this is just the nature of us trying to figure out how to do this. So.
Thank you.
George.
Just a clarification, following up the concept that, you know, maybe wildfire season is year round and ozone season is not. Several years ago, the ozone season was extended. The classic season was May to September, depending where you are in the country, and it varies, but it can be March through October. Now, that's still not year round, and maybe it should be. Also note that in the NCORE sites, and I think there's 75 or so of them, both some urban and some non-urban, ozone is year round. So there are, you know, there's some and, you know, year-round data available out there, but that doesn't mean we couldn't recommend that all ozone sites go year-round. There may be some value to that, but you also have the issue of constrained state and local agency resources too. So,
Thank you, Christina.
Okay, so I just wanted to triple check what Terry had just said. So there's no possibility of any of the changes that we are highlighting or things that would like to have to make any changes to the ISA. We're only going to be keeping those things in mind that we would like to have changed when we are doing the PA.
Well, yeah, I guess
Well, reevaluating the PA.
Yeah, I mean, our advice, since we have a draft PA, presumably would affect the final document. So I think that's a correct conclusion. And restating what I said, I think with respect to the science, we can provide advice that affects future research and future ISAs. So some of these conversations, I think it's almost impossible for us to completely separate when we're thinking about these topics, how to think about what's important without having a bit of a discussion. So some of it naturally strays into at least an appearance that we're looking to revise the current ISA, which we are not, because EPA will not be doing that. But we need to understand it well enough to provide advice for the policy assessment in our upcoming meeting. And also our consensus comments should prioritize future research as well as future ISA suggestions. So does that help answer your question?
Yes, just wanted to hear it again. Okay, thank you.
Yeah, and I think we're all struggling a little bit with navigating, and particularly a topic like this one, where you could have argued that we didn't even need to put it on the list, but there were several things that came up in our earlier meetings that people wanted to discuss. So I tried to be complete in our discussion points. Anything else? We'll come back to this, so maybe we don't need to close out this discussion and check and see if Jim has what he needs, because we're going to come back to it. Any other questions or comments today on this topic? Seeing none. And unless anybody has anything they would like to bring up, I think I'm going to turn the meeting back over to Aaron. We will discuss the health effects endpoints on according to the agenda. So on Wednesday, we have the respiratory, cardiovascular, and mortality discussions, and I expect those will probably be fairly robust discussions. And I don't expect us to move on to the topics for Friday, the developmental or at-risk communities, and we'll also come back to this atmospheric question. And we'll see how our discussion goes. If we need to, we might spill over our Wednesday discussion into Friday. That's, I think, the more likely thing, but we'll see how it goes. All right, Aaron?
Yes, so we can be recessed until Wednesday, 11 a.m. Eastern time. We'll see you all then again.